Assalamualaikum and a very good day to our panelists, Dr. Helmi bin Rashid and Dr. Amalina Binti Amir, and to everyone watching this presentation. My name is Nasrul bin Zamri, and I will present to you my final year project proposal, Structural Integrity of Clamping Device for Workover Riser System. This project is under supervision of IR Hazran, Husain, and Co-supervisor Mr. Muhammad Suhairil, Meon. First, let's go through the content of this presentation. This presentation will include project background, a brief findings on the literature review, problem statement, objectives, scope and limitation of the project, methodology of the project, and lastly, the results or the outcomes expected to be gained from this project. The title for this project is Structural Integrity of Clamping Device for Workover Riser System. Our main focus is on the clamping device itself. What is a clamping device? A clamping device is basically a device used for repair purpose on subsea pipelines. A clamping device is typically used to encase damaged region of a pipe. It covers the damaged part from being exposed and prevent further damage. A clamping device is basically a metallic-based device consists of two-piece flange shells with oversized annuli that fit over the pipe, with perimeter elastomeric seals for fluid containment. The flanges are bolted together so that the clamps are fixed together. Seals is one of the most important part of the clamping device. A seal is used to prevent leakage, to seal the liquid from leaking. What about pipeline and riser? Subsea pipelines are connected to a riser as can be seen in figure 2. Damages can happen on the pipelines or risers after its life expectation is exceeded or due to environmental factors such as corrosion. There are many types of damages that can occur to pipelines and risers. One of the damage that can be fixed by using clamping device is leakage. Leakage can be caused by internal or external metal loss, and sometimes due to crack in welded seams joint or on the pipe. Based on findings from literature review, there are many types of damages can occur to pipeline, which includes gouging, denting, and corrosion. Corrosion is one of the most common damage that frequently happen. It is the main factor that causes failure in liquid pipelines and one of the top 3 factors for gas pipelines failure. Based on findings, loads acting upon pipes can change due to several factors such as leak tightness of pipe, aging of pipe, low quality of materials, and poor pipe installation. As mentioned earlier, clamping device can be used to repair pipe leakage. Using carbon steel as material for clamping device is a great idea as it can cut costs. But there is one drawback using this material. Carbon steel has low resistance towards corrosion. But this problem can be solved. Corrosion can be prevented by coating the carbon steel base with alloys, which has higher corrosion resistance. Based on the findings, structural integrity and material strength of the clamping device can be analyzed using finite element analysis. There is a few problems in this project. First, how stable is the clamping device? Second, how big is the stress and deformation of the clamping device due to forces distribution from pipe? Deformation and stress can occur due to the clamping force exerted on the pipe. The aim of this project is to examine the structural integrity of the clamping device under load without breaking or deforming excessively the structure. Second, the purpose of this project is to analyze the material strength of clamping device with different thickness. What are the scopes and limitations of the project? As it has been decided to design the clamping device using a CAD software, CATIA. The drawing and dimensions of the clamping device is obtained from a client. The model designed in CATIA will then be imported into ANSYS using either step file or IGS file for further analysis. Material to be applied for the clamping device is grade 70 carbon steel A516. The analysis will be done with 3 different thickness of clamping device, which are 48mm, the original thickness 50mm, and lastly 52mm. It is also considered that the force distributed from the pipe or the center of the design is uniform. Methodology of the project. A flowchart has been constructed to show the workflow of the project. Started with CAD modeling using CATIA to build the model of the clamping design. It is then followed by structural analysis using ANSYS. The model has been imported into ANSYS using IGS file type. The analysis using ANSYS will be done during phase of final year project 2, which is next sem. The results will then be obtained after the structural analysis is conducted. Final results that have fulfilled the objectives of the project will then be discussed in the final thesis. The following figure 9 shows the model of the clamping device designed and drawn using CATIA, while the next figure 10 shows the imported design into ANSYS. The material properties of the clamping device has been decided to be used grade 70 carbon steel A516. As mentioned earlier, different thickness will be used: 48mm, 50mm, and 52mm. The material properties are as follow. The ultimate tensile strength of grade 70 carbon steel A516 is about 485 to 620 megapascal. The yield strength is 260 megapascal. Modulus of elasticity is 200 gigapascal. Poisson's ratio is 0.29 and shear modulus is 80 gigapascal. The result that we expect out of this project is that we are able to identify the structural integrity and material strength of clamping device under load without breaking or deforming excessively the structure. The clamping device should not break or deform due to the force distributed from the pipe. Second, the structural integrity and material strength of clamping device with different thickness is able to be analyzed. Through these results, the best thickness can be suggested, either 48, 50 or 52mm. The material used also can be decided whether it fits the application for damage repair on pipelines. That's all from me for proposal presentations. Structural integrity of clamping device for workover riser system. Thank you to my supervisor IR Hazran Husain and co-supervisor Mr. Muhammad Suhairil Meon for their guide during this FYP. And thank you to panelists Dr. Helmi bin Rashid and Dr. Amalina Binti Amir. For any questions, please do not hesitate to contact me. Thank you for your time.